Okay, students, let's continue on type 2, which is discontinuous integrals. So the second type of improper integral is related to the discontinuous integrals, which means if we have infinitely many points of discontinuity to me. So let's see this definition. If f is continuous on a closed interval, ab, open interval, b, and is discontinuous at b, you see, the discontinuity is at b, then you can say that the integration from a to b, so the problem is on b, yeah? Because the function is not continuous at b. Therefore, you can use similarly limit, the limit from a to t, but t must be approaching to b minus. Why not b plus? Just make it a single line and define the interval a to b. So here we have a, and here we have b, okay? So we are allowed to move in this territory only from A to B, from A to B. So I have right towards B, left side, you see, but I couldn't come this way. I'm not allowed because the interval given is from A to B. So when I am approaching B, I have only one option, that is B from the left to me, B from the left. That's why. So if the discontinuity is at B, we can say that the limit from a to t, that is t approach to b from the left of f of x dx is correct to me. And if f is continuous on this from a to b, which means now we are allowed, this is open interval and b is closed interval to mean. So we don't have problem at b, but at a to mean. And the only option that I can approach a is from its right side. That's why we have that the integration from a to b f of x dx is simply the limit as t goes to a from the right. You see, a must be approached from the right side only. And this one is t, the lower integration, I mean lower limit of integration. And we have no problem with b, then we'll apply limit on that to mean. So as in the type 1, we have seen if the limit of this improper integral exists, we say that the improper integral convergent, okay, it converges to mean. Otherwise, we have to say that it is divergent to mean. So it depends on the existence of the limit that you are considering here. Maybe you can face that f is discontinuous at a certain point. See where c is between the intervals a and b. And you can say that both the integration from a to c f of x dx and the integration from c to b f of x dx are convergent. Then we define that the integration from a to b f of x dx, the discontinuity is what? Somewhere in the middle, okay? Suppose this is a and this one is b. But the integrand function could be discontinuous at a certain point c, which is between a and b. Therefore, this integration from a to b, that you can see it, could be changed into two integrations where one is laid over this from c to b and the other is from a to c. That's why we write is like this, from a to c f of x dx plus the integration from c to b f of x dx. But mind you that the discontinuity is at c, okay, at c. Therefore, these are like integrals that we have seen in a and b to mean. Okay, let's see some example and then we'll wind up the topic about improper integral. Suppose you are asked to solve this integration. It says the integral from 2 up to 5, 1 over the square root of x minus 2 dx. So if you go to solve this by definite integral, which means you are going in the wrong direction. Because this at x equal to 2, we have vertical asymptote, yeah? Vertical asymptote. So such problem is related to improper integral. This is improper integral, okay? Why improper? Because we have what? Some discontinuity, infinitely many discontinuity on the function. Therefore, in order to solve this, we have to apply the integration from 2 to 5, 1 over the square root of x minus 2 dx is equal to the limit. The problem is where? At 2, yeah? The problem is where at 2 is from t to 5, 1 over the square root of x minus 2 dx. So is t approach 2 from the right or from the left? Just simple technique is draw. This is 2 and this one is 5. So if you are approaching towards 2, you have only one side, that is right side. Therefore, this one must be what? 2 from the right. So what is the integration of 1 over square root of x minus 2? It is very simple, yeah? Because you can solve it easily. The antiderivative of 1 over the square root of x minus 2 is simply 2 times of the integration of, square root of x minus 2, t goes to 2 from the right. Please solve this by any technique, okay? It is simple. And we have to evaluate at t and 5. Then let's substitute 5 and t. So here we have 2 times of the square root of 5 minus 2 minus of 2 times of the square root of t minus 2 as t goes to 2 from the right. So this is 5 minus 2 is 3, and this will be 2 root 3 minus 2 times the limit of the square root of t minus 2, t goes to 2 from the right. You see, 2 from the right means it is a bit greater than 2, but they are almost the same, yeah? But we know that the square root of 2 from the right minus 2 is different from, it is defined to me. So this will go to 0, and we'll obtain that 2 root 3 minus 0, which is 2 root 3, yeah? So since the limit exists, we can say that the improper integral converges. Okay, converges to what? Converges to 2 root 3 to me. And this is a graph of 1 over square root of x minus 2. You can see that at x equal to 2, this is x equal to, we have vertical asymptote, which is in blue color. That's why we have infinitely many points of discontinuity, okay? This point is different from this point, yeah? This point and this point. How many points do we have? Infinitely many points of discontinuity we have to mean. So that's why it is improper. Improper. Okay? Improper. Now, if you take the area under the graph 1 over root of x minus 2 from 2 up to 5, this will obtain 2 root 3 as you already obtained here. Okay, let's add one more example, and then I will give you one homework or exercise for yourself, then we'll wind up. Evaluate the integration from 0, 3 dx x minus 1. Let me show you common error. The common error, usually students do like this. The integration is simply 0 from 3 dx x minus 1. But we know that the antiderivative of 1 over x minus 1 is ln of absolute value of x minus 1. Then we evaluate at 0 and 3. This is like ln of 3 minus 1. Okay, minus ln of minus 1. Simply, students do it like this, okay? And just we can put like this, but this one is wrong answer, okay? This is not correct. Okay, not correct answer. Why? This is wrong. Why? Because this is not definite integral, okay? Because this integration from 0 up to 3 is improper, okay? There is discontinuity at what? Here we have the interval given is from 0 up to what? Up to 3. But we know that at 1, at x equal to 1, we have vertical asymptotes. Okay? At this point, there is a problem, yeah? Now, If you remember, yes, we can use this method because the discontinuity is between A and B. So our C will be what? Our C will be number 1. Number 1. Therefore, you have to, the correct one is what? The integration from 0 to 3 dx over x minus 1 has to be solved as what? The integration from 0 to 1, where 1 is a discontinuous point, plus what? From 1 up to, is that 3? Yeah, 3 dx over x minus 1. Now we have to solve this one by one. We can say this one A, this will be B, then we'll add them. So let's solve A. A is what? The integration from 0, 1 dx over x minus 1 to me. How to solve this? Just this is simply what? Ln of absolute value of? No, I should use limit. Yes, because it is improper. At what? At 1. This is the limit of the integration from 0 up to t dx over x minus 1. T goes to what? T goes to 1. From the right or from the left? Just simple check. Here we have 0. Here we have 1. Now we are approaching towards 1. So this one is what? This one is left of 1. So this must be 1 from the left to me. Okay, now when we do this, I have to come up with the integration of dx over x minus 1 is simply ln of absolute value, yeah? Ln of absolute value of x. Okay, so this is the limit of absolute value of x minus 1 as t goes to 1 from the left. This is from 0 up to t. They substitute the limit of absolute value of t minus 1 minus limit of, no, this is ln. We have ln here. Ln of 0 minus 1. T goes to 1 from the left. And this is simply, let me finish it here. It is simply the limit of ln of t minus 1. T goes to 1 from the left minus 0. Because ln of absolute value of minus 1 is ln of absolute value of 1. And ln of 1 is 0. So the answer is what? What is the limit of ln of t minus 1? As t goes to 1 from the left. You see? When we are approaching t from 1 from the left, which means we will have very small number, negative 0.000 something. So ln of this very small number is simply went to minus infinity. So minus infinity to 0 is 0. Therefore, this one is what? Is divergent. Infinity ስለሆነ minus infinity ስለሚሆን minus infinity. That's divergent. Divergent. ሁለተኛው ፓርት ምንድን ነው? The integration from 1 up to 3 dx over x minus 1. Just we don't need like to do this, huh? No need to do. No need to do. Why? Because if one of the summation is divergent, which means the whole summation will be what? Divergent. So as to me, it is not important to figure out the integration, the improper integration from 1 up to 3 dx over x minus 1. No need to do, because one half part is like the integration from 0 to 1 dx over x minus 1 is simply what? Divergent, yeah? So the difference is, in this case, when we do it wrongly, it is like ln of this absolute value, ln of absolute value of 2 minus ln of 1, you see? Which is like a certain answer, but this is not correct, really. So mind you always, when you solve even some of the integrations that seems definite integral, they are not actually definite integral, rather they are improper integral. So you have to mind such integrations before simply going to evaluate by assuming that the given integral is definite integral. No way. Okay, this will be your exercise by yourself. And it says determine whether the integration from 0 to pi over 2 of sec x dx is convergent or divergent. So why this one is improper, just let me give you hint, because the integration from 0 to pi over 2 sec x is what? Is simply what? Sec x means 1 over cos x, is it? But cos x is undefined at x equal to pi over 2. Is not defined, yeah? Which means there is infinitely discontinuity on x equal to pi. This is the vertical asymptote. That's why you treat this as what? As improper integral. So knowing this, the problem is at pi over 2. I think you can find the improper integral as what? The limit of the integration from 0 to t of sec x dx. But t must goes what? T must goes to pi over 2. Is that from the right or from the left? Just simply cross. Here you have 0. Here you have pi over 2. So we have this option that is approaching pi over 2 from the right side. And get the answer. If you obtain a single number, which is in the set of real number, which means it is convergent. If it goes to infinity or minus infinity, which means the improper integral is divergent. So with this, we finish our today's topic. And by tomorrow, I will give you additional examples on application of integration, okay? We have already solved some example on application of definite integral, and I may add on finding some applications of volume. Okay, all the best.